I don't think that's a problem. You can stay here. So when I'm saying that this phone is a good phone against that this phone is a great phone, there is a difference between, because both this opinion, good and great, are positive, but there is a difference in the subjective belief, right? The degree of subjectivity. So for example, you can give a +4 to great against you can give a +2 to good. So in that, for that reason, this kind of, that uh, summarizations may be reasonable. So we are giving extremely clear +3 and amazing +4. So we are giving different magnitudes of the subjectivity rather than the just the positive or negative. So this person continues to read a number of reviews, right? But while some of the reviews will be in agreement with whatever he has read, some of them will be in disagreement, right? And so that creates some other kind of confusion. Okay, so and so reading all the reviews is practically impossible task to do over there. So what this person can do is that he can select a number of reviews, okay, and he can kind of create a summarization like that. For example, he is interested about these 4 product features like camera, display, battery, and price. And he can read the reviews, and what he can do is that he can count the number of positive words mentioned for camera, the number of negative words mentioned for the camera, and count that how many thumbs up and thumbs down we have, right, basically. And so that's how he can basically decide upon that how much score to give for each of the features, right? So the online retail giants like Flipkarts and Amazons have created summaries like this, the aspect-specific summaries, which kind of says that how much ratings we have for cameras and the batteries displays. So I went through the Flipkart tech blog to understand that how this is being done. But not much information was available. I think probably, I don't know, I'm not sure, that this may be the average of the ratings for all the reviews that mentions camera in that. And if it is like that, then we have a problem, because a review getting high review doesn't necessarily imply that it's talking good about camera. Okay. So we had created a summary that looks like this. Okay. So the students of the Praxis Business School had created a summary that, as a part of the capstone project, that it's basically a prototype, that you will have a number of phones over there. So we go to this section, and there will be an option called Get Feature Score. Okay, so. The vertical bar plot that we have over here is basically called the feature buzz summary. It's a number of times a feature has been mentioned in the reviews, okay? And over here, we will have a donut chart, okay, that says that out of all the opinions that we have for a specific feature, what percentage of them are positive and what percentage of them are negative. For example, just front camera, for this particular phone, we have 72.6% of the reviews which are positive, okay, and 27% of them are negative. So we have a number of features over here, okay, and if you click any one of them, it gives you a chart like that. So in the early 2000s, the problem of sentiment analysis was a very new problem, okay? So some amount of work was done on document level sentiment analysis. So it's basically a framework where you just put in the entire review, okay, and it's going to say that whether the customer who has written the review expresses a positive or negative opinion or a neutral opinion about that particular product. Okay, so but in 2004, the Professor Bing Lui and one of his PhD student, Mingking Hu, now they have proposed a very different kind of text summarization approach. They said they introduced this feature-based opinion mining problem, right? So what the process involves basically mining all the features that are being mentioned by the customers, number one, and secondly, what are the opinions of the customers associated with them. So they're published, the prominent work involves these 4 works, okay, so there are many others. In the first, they published 2 papers in 2004. The first paper is about, that how to identify what are the features that are being mentioned by the customers in the review, number one, right? And it's not involving a template approach, a template matching approach. So we are just not in search for the camera, mentions of the camera in the review, okay? And the second one is that about a little bit of modification on the first one and the focus more on the summarization part. And it basically says that out of all the features that are being mentioned, what is the opinion associated about each of the features? Then in 2005, they published another paper. They proposed a system called Opinion Observer. And what they were doing is that they were comparing competitive products based on the opinions given by the customers. In 2010, Ping Lui, published a chapter called Sentiment Analysis and Subjectivity, where he formally defined the problem of sentiment analysis and opinion mining. And this particular chapter focused more in two problems. First is feature-based opinion mining, and second one is opinion spam. Okay. So every product, you see, can be seen as an object. For example, so a cellular phone. It can be seen as an object, right? An object will have a number of components. For example, a cellular phone will have a number of components like camera, battery, and display. And these components will have some subcomponents or an attribute. For example, a camera will have a front camera, back camera, and rear camera. Now, back and rear camera are the same thing, basically. So those are the things that are also needed to be mined. Okay. Now, battery will have a number of attributes like battery life, size, performance. Display will have a number of attributes like size, quality, and type. Right. So an object can be represented as a tree, hierarchy, or taxonomy. Now, because NLP is a difficult problem to solve, right, it's often useful to simplify this hierarchy, eliminate this hierarchy, and flatten out this definition of object and just say that this object will be composed of a number of features. Okay, so where the object itself can be seen as a special feature. Okay, because a person can have a direct opinion on the object itself. Okay. So now, depending upon how the features are being mentioned in the review, we may have two categories of feature. One is the explicit feature, the other one is the implicit feature. For example, consider the first review. It says that the battery life of the phone is too short, and it mentions a feature explicitly, which is the battery life. And in the second review, it says that the phone doesn't fit in an usual jeans pocket. Now, here, the person is talking about the size of the phone, which is not explicitly mentioned by the reviewer, right? But it's an implicit feature. The next one, don't know why I spent so much of money for the phone. It's basically something which is not value for money, again, a feature which is not explicitly mentioned by the reviewer. Now, implicit features are, that very difficult to mine. Okay, so compared to the explicit features. In the same way, you can have explicit opinions and implicit opinions. Explicit opinions are opinions where the customers are explicitly mentioning about the opinion in the review. For example, the display clarity of the phone is amazing. So it's a positive opinion expressed explicitly in the review. And the implicit opinion is like the phone doesn't fit in an usual jeans pocket. It's basically a fact which expresses some amount of dissatisfaction or disappointment. Okay, again, an opinion which is not explicitly mentioned in the review. Okay. So the problem of feature-based opinion mining can be solved using mainly the 5 steps, okay, as suggested by the Who and Lu system. And the first thing is identification of the frequent features, means let's identify what are the features that are being frequently mentioned by the customers in their review. The second thing, for all the features that are being mentioned in the review, let's try to understand the opinions associated with them. And after understanding the opinion, let's try to identify the opinion orientations. That means how many of them are positive, negative, or neutral. Okay. Using the first step and the second step, we will mine the fourth step, which is identification of the infrequent features, means the features which are very less mentioned in a review by the customers. Okay, so they're a little bit difficult to identify. And finally, putting everything together to generate some meaningful summaries. So we'll start with the step 1, which is the identification of frequent features. Okay, and if you note, if you look this review very carefully, it will be very interesting to understand that the features are basically nouns or the combination of nouns. Okay, so front is a noun, camera is a noun, phone is a noun, rear camera, there's a combination of nouns, right? But it should also be noted that not all the nouns that we have in these reviews are features. Okay, so Who's and Lewis system are based on this idea that the nouns which appears more frequently may qualify as a feature. They're not saying that it certainly qualifies as a feature, okay, but they may qualify as a feature. So let's extract all the nouns from this review. So these are all the nouns that are extracted from this review. Now, after isolating all the nouns, it should also be understood that, that there is an association among the nouns which makes the noun combination meaningful. For example, the noun front goes more with the noun camera, and that's what makes a meaningful feature. Battery and backup together makes a meaningful feature, right? And so the word front is not so much associated with the word battery. Okay, so those associations are needed to be mined. So we can use an association rules mining to understand that which nouns are more associated with each other, and identify that what are the more frequent features, right? So that association rules mining will solve two problems. So for each of the reviews, what we will do is that we will extract all the nouns. Okay, so this can be seen as a transaction matrix, that where each of the rows can be seen as a transaction, ID, right? For each of the reviews can be seen as a transaction IDs. And these are the items, right? And this can be represented in the form of binary representation like this, where each of the values, zeros and ones, are indicators whether the nouns are present or not. The POS tagging algorithm which categorizes each word that whether that's a noun, verb, adverb, adjective or not, right? So it's a sequential algorithm. Okay, so it tries to understand, given all the words that we have, what is the next possibility of the next word is going to be. It's a verb or a noun. Okay. And so after getting that tag, we basically take out all the nouns. So that's what we're doing. In? They're available? Yeah. Yes. Right. So we use that. So we used some Python packages, like in the NLTK there is a POS page tag, in Sparsy there is another one. So we use that model to get the nouns out. Okay, so after getting the nouns out, we are basically represented as this is a binary representation which indicates the presence or absence of each of the nouns in the reviews. For example, I will give a very basic example that I've got 10 reviews and I've got 7 nouns over there. In the first review, we have the word camera and the battery present, but the front is not present over there. Okay. Now, a noun or a combination of noun will be interesting if it satisfies a minimum support threshold. Okay, support is basically the probability of each of the nouns coming up, or each of the combinations coming up in the reviews, right? So, for example, the word camera appeared 7 times in the review, out of 10 reviews, so the support of the word camera is 0.7, right? So similarly, the support of the word battery is 0.6. Okay, in this way, we can calculate the support, and we can set a threshold, and we'll say that if the support of an item is more than that threshold, so we'll consider that as interesting. In the same way, we can calculate the support of the combination of words, like support for the word camera and front. Okay, so what we'll do is that we will focus on these 2 columns, and we'll say that in how many reviews both of these words appear together. Right, and we see that in 4 out of 10 reviews, these words appear together, so the support is 0.4. Okay, so you can also calculate the support between the battery and front, and you will see that there are 2 out of 10 reviews where we have these 2 words coming up. But also note one thing, that in all these 2 reviews, we do have the cameras turning up as well. Okay. So the battery and life will have a good support because it forms a meaningful features, and a lot of people might have mentioned about battery and life in the reviews. Right. So as I mentioned, that a noun or a combination of noun will be considered interesting if it satisfies a minimum threshold. This is a small problem. I've chosen a threshold as 0.4, but for the larger problem that we were solving, we selected a threshold of 0.01, that is 1%. Okay, so if any of the noun or noun combination appears at least in 1% of the review, we'll consider that as interesting. These are some of the experimental results coming out of the experiments that we have done. Okay, so we have taken the reviews of the phone OnePlus 6 from Amazon.com, and we have done the same, taken the same approach over here. And this is the result of the association rules mining. So we have a set of features where we have only one word appearing as a feature. Okay, and then we have another set where two words appeared as features, right? Two noun combination. And so the camera quality, battery backup, phone problem, value for money. So we have some very meaningful features coming up, right? Over there, charger, price, budget, speaker. Now, but see that we do have life over here as a noun coming as a feature, right? So life is not a feature, but this life, when it appears with battery, that becomes meaningful, right? Now, the word front, when it appears with camera, that is a meaningful feature rather than just the word front. So what we need to do is that we need to eliminate all these nouns or the noun combinations which are kind of meaningless as features. Okay. So for these, we will use a pruning technique. Okay. So what we'll do is that we'll just prune out all those meaningless words or the word combinations that's appearing as features. Okay. So the first kind of pruning that we are going to use is called compactness pruning, and what it does is that this method checks whether a feature, this method checks features that contains two or more words. In this case, we will limit ourselves to two words only, okay? And it will remove all those words that are likely to be meaningless, okay? And how it's doing that is that, say that I have a sequence of sentences, okay? And I have a feature that comprises of, consists of two words, word one and word two. Okay. And so for every sentence that we have in S, we need to check that whether both these words are present in the sentence or not. And if they are present, we will count how many words separate these two words. Okay. Now, if the count of those number of words separating those two words, okay, is less than 3, we will say that these two words, W1 and W2, are compact. Okay, so they come closely with each other. Okay. And for one particular feature, okay, so if that feature occurs in M sentence, now M is something that which you need to define, okay, and this F is compact in at least 2 of these sentences, then we'll say that this F is a compact feature, okay. So, yes, sir. Uh-huh. Yeah, so you can use the top. No, we actually use topic model algorithms, but we weren't getting some very meaningful viewpoints, because topic modeling, what it does is that also topic modeling won't be something that where you always need a human intervention. So you need someone to sit and decide what are the topics that are coming up for each of the features. So topic modeling did not work very well for this kind of reviews. So that we did experimentally. We'll talk about that. Yeah. And so, for example, that I have a feature, camera quality, which has got 2 words, camera and quality. See, the first review which says the camera quality is really good, it's a compact feature, right? Because they are not separated by any words. The second one, I love the quality of the camera. This quality and the camera separated by 2 words, again a compact. The third one, awesome camera, and the phone comes with a quality display. They're not compact because they're separated by more than 2 words. Okay. I got a counter example as well, that the phone has an awesome front camera and a quality display. And over here, the word camera and the quality are compact, okay? But we do not have a dependencies between them, okay? So we may face a challenge for this kind of cases. So there are some more counter example. For example, consider 2 features, camera and battery, okay? So, and you see that both the camera and battery is good. If it's a review, then the battery and camera are coming compact, right? So because they're not separated by more than 3 words, okay? Now, so although all the good camera but not a good battery is again compact, lovely camera quality and nice battery. But that in all these 3 cases, you see that these 2 features are basically separated by a conjunction. Right. This is what we see in the usual cases. They may be separated by some punctuations as well. Okay, so need to be analyzed separately. So what we decided to do is that we decided to add another line to the compactness pruning algorithm that's suggested by the Lewis system. And what we said is that for every sentence that we have, check whether W1 and W2 are present in that sentence, and then further check that if W1 and W2 doesn't contain any conjunction between them, right? So, because if they contain conjunction, then they cannot be compact. They are not one feature, okay? So they are separate things, right? And the rest of the algorithms remains the same. So if the count is less than 3, we'll call them as compact. So this is how, this is what makes possible to remove all those features, okay, so which appears as a pair, noun pairs, and which are not meaningful. So this will eliminate all these features like display battery. Because of the conjunction thing, we were able to remove all those things over there. Okay, so we have time camera, which is anyway not meaningful, and so it just gets eliminated with just an usual compactness pruning algorithm. Now the second one, this one is pretty interesting. It's something called as a redundancy pruning. Now what this redundancy pruning will do is that it checks features that contain single word and remove those that are likely to be meaningless as a feature. Okay. So we calculate something which is called as a Pea Support or Pea Support. Okay, so I'll just read the technical definition of the Pea Support, then I will give you an example and come back to the technical definition once again. It says that the Pea Support of a feature F is the number of sentences that F appears, and these sentences must contain no feature phrases that is a superset of F. So we'll break it down. Okay, consider this example, then we'll come back again. Okay, so Pea Support of a feature F, let's consider that we have a feature called camera. Okay, is the number of sentences in which F appears. So camera appeared in 100 reviews. Okay, and these sentences must contain no feature phrases, which is a superset of F. Now let's consider some other features like front camera, rear camera, back camera, and the camera quality. These are the superset of the feature camera because all of these features contains the word camera in it. Okay, and then out of 100 of these reviews where the word camera appeared, you see that in 20 of them front camera appeared. Okay, so camera appeared with front. Okay, in 15 of them this word camera appeared with rear. Okay, in 23 of them camera appeared with back, and in 100 of them camera appeared with quality. Okay, so Pea Support is basically those reviews or those many reviews where the camera appears on its own. Okay, for example, just take 100 and subtract the sum of all these numbers. So what you're left with, 32. So that's basically the number of reviews where only camera appeared as a feature, and therefore the Pea Support for the feature camera is 32. So we need to calculate the Pea Support for all the features which occurred as a single word. Okay, and then we need to get a threshold value, right? So now if the Pea Support exceeds this number, then we'll consider that the feature is a meaningful feature. So this will help us eliminate all these words because the word performance, that itself is not a feature. Okay, so it comes with something else. It may be the camera performance, it may be the battery performance, or the phone performance, right? So it won't come just on its own. So it will have a very low Pea Support value, and therefore those things will be removed. Like the word heat probably comes more with battery, okay, and so it will have a very low Pea Support value, and therefore, or the heat can come with phone as well, have a very low Pea Support value, and therefore will get removed. So here's where we stand. We have the review database. We'll pass it through this framework. So the first thing first, we'll do a POS tagging. We will extract all the nouns, right? And so we will represent the data in the form of binary representations, where in the rows we will have the reviews, and in the columns we will have the nouns. We will do an association rules mining to extract the frequent features, okay? And after identifying the frequent features, what we need to do, we need to pass it through two pruning algorithm, the compactness pruning and the redundancy pruning algorithm. And we will get the set of frequently mentioned features by the customers. Okay. Next thing is that for all these features that we have extracted, what we need to do, we need to extract the opinion words associated with each of the features. Okay. So what means the whose system had suggested that based on some of the previous research work on subjectivity, which said that the presence of adjectives in a sentence, okay, so it what qualifies a sentence as being subjective or opinionated. So they decided to consider all the adjectives which are nearest to the feature, okay, as an opinion word. For example, over here we have the feature in the first review. The camera of the phone is good. The camera is a feature, okay, and the good is the adjective which is nearest to the feature camera, okay. So the word good was being extracted as an opinion associated with the word camera. The display looks dull, okay. Again, said the dull is an adjective which is associated with display. So just extract dull as an as an opinion for the featured display, okay. So just get the nearest adjective and consider them as an opinion. That's what was suggested, right? But if you're doing that, we do have some problems. For example, if you have reviews like this, that the camera of the phone is extremely good. So if you're just extracting adjective, you will just end up extracting good, okay? So but extremely good and good has a clear difference, right, in the opinions. The headphone is not working. Now here we do not have an adjective over here, but clearly it's a dissatisfaction shown by the customer about the review. So it's basically a negation and a verb, okay, so which is also needed to be extracted. The speaker of the phone is doing great. It's a verb plus adjective combination. The feature has some nice cool features. It's an adjective plus adjective combination. So if we were extracting just adjective, we would have ended up just extracting nice as the opinion, okay. The display is not bad. It's basically a negation plus adjective, okay. So all these features, all these combinations are needed to be mined, okay. So we modified this algorithm of extracting the opinions in this way, that let's consider if as a feature, and we have a sentence, okay. So basically we have a review which consists of a sequence of sentence. Let's denote it by S. And for each of these sentences, check that whether the feature is present in the sentence. Identify the nearest adjective or verb in F, okay, if that is present. Now, what we're doing is that for that particular sentence, just identify whether the whether the adjective or the verb is nearest to the feature. If, in case the adjective is the nearest, then further check that whether that adjective is preceded by an adverb or a negation. Okay, so the word before the adjective, it's basically an adverb or a negation. Because if it's that, then instead of just considering the adjective, we need to consider the pair adverb / negation, comma the adjective. Okay. Else if the adjective is succeeded by an adjective, okay, so like nice and cool, right? So you need to consider opinion as the pair, which is adjective, comma adjective. Okay, otherwise the opinion is going to be only the adjective, right? Now if the verb is the nearest, okay, then check that whether the verb is preceded by an adverb or a negation, okay. So if the verb follows, an adverb or a negation, the verb has an adverb or a negation before that, then the opinion will be the pair adverb or negation, comma the verb, okay. Otherwise, further check that whether this verb is preceded by an adverb or adjective, then we need to take that pair, okay. Otherwise, we'll just consider the verb as an opinion. For example, the phone is working, so that verb will be taken as an opinion, okay. So the next thing is that let's just identify the opinion orientations. So what you can do is that for all the opinions that you're extracting, you need to get the orientations of each one of them. So what you can do is that you can use some kind of dictionaries, so what the magnitude and the signs of the opinions are already listed, okay. For example, say that I have mined a list of adjectives. Say that let us just limit ourselves to adjective first. Okay, we have mined a list of adjectives, and we need to check that whether this word is present in this seed list or in this dictionary or not. Okay, so if it is there, for example, beautiful is there in the dictionary, okay, and we need to just get the opinion like +3 for that word, okay. But the problem comes that when some of the words in this adjective list is not present in the dictionary, okay. So there's the problem happens that what we can do is that we can use WordNet. Okay, so but the adjectives are organized in a bipolar clusters. Okay. And so what we will do is that, see, See, one thing that why it's called that the adjectives are organized in bipolar clusters is because on one side we have the synonyms of the word fast, okay. On the other side we have all the antonyms of the word fast, okay. And so what we can do is that we will see that if the word fast is not present, let's check that if a synonym of fast, the word fast is present in this list or not. So for example, the word swift is present over here, okay. And so, the fast also gets a polarity too. Okay, so we have the word swift over here, which gets, huh? What is, WordNet is a library, it's a package, so where the words, where the adjectives are arranged in bipolar clusters, right? So it's basically an arrangement that is created by linguistic and the artificial intelligence experts, okay. So it's a basically a library, huh? Mm-hmm. No, we won't get it using this thing, right? Yeah. Yes. So we use different libraries for that, right? No, plus means a positive opinion. Okay, the orientation of the opinion is positive, and then we have the degree of subjectivity as indicated by these numbers. Okay, for example, the word awesome is +4, and we have the word beautiful as +3. Okay, so that means, yeah. No, 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 we are not assigning anything. There is a library, there is a word list called affine. Okay, so we were basically using that word list to get this. Sorry. Correct. Yeah. The intensity of my subjective belief. So that's what is indicated by the, that those numbers. Okay. So that. So the reason why WordNet works is that basically the adjectives share same orientations with their synonyms and opposite orientations with their antonyms. So if the word swift wouldn't be present over in the list, then we would have searched that whether any of its antonyms were present in the seed list, right? Huh? Sarcasm is something that we didn't work over there, okay, but it's kind of, I think that one of the way to detect sarcasm is to be very domain specific. Okay, so be very domain specific and try to understand what sarcastic comments can come for a specific, related to a specific domain. So what may be sarcastic for one domain may not be the same for some other domain, right? So that could have been a good start for, huh? Now, that domain specific in the sense, that I'm just not able to come up with an example right now. Okay, so but so no, there is no definite way to do that, right? So there is no definite way, but that sometimes that based on such certain scenarios, so we just bring the sarcasm up, right? Okay, so I say that this is working very well. It's actually sarcastic comment. So I spend a lot of money and this is working very well. It's basically sarcastic comment, but this setup is going to take a positive comment over there, right? But that word may be very differently seen for some other domains. That's what I'm saying. Uh-huh. Uh-huh. Right. No, so you need to have a dictionary of slangs, basically. That. So we need to have a dictionary anyway to identify that. Whether that's. Yeah, yeah. Right. So. Now, for this kind of things where we have this combination, so we were basically using the Python package called Sentiment Intensity Analyzer. So that was actually taking in these opinions and giving us a score for each of these, that opinions. So this is very different from the approach that I was talking using WordNet, because WordNets can only quantify the opinions for adjectives. Okay. So far, whatever we have done is that we have taken the review database, passed it through the frequent feature mining framework, which involves the POS tagging, the frequent features identifications, and the feature pruning. And then we extracted the opinions for each of the words, okay, and identify the opinion orientations. And then this method can be used to identify the infrequent features. And I will tell you a way to do that. That just look at this review very carefully. One is saying that the picture is absolutely amazing. The software that comes with the picture is amazing. Now this picture, let's consider that as a frequent feature. And the software is a feature which is not frequently mentioned, and let's say that that's an infrequent feature. Okay. But see that both of these features share the same opinions. Okay. So what was suggested over there is that just let us see that what are the opinions that are associated with the frequent features, and then let us identify the infrequent features, with those opinions. Okay, so the algorithms that they basically suggested is that if none of the frequent features are found in this review, in the second one, but one of the opinions that was associated with the frequent features was found over there, and you identify that, then consider the nearest noun as the infrequent feature. Okay, but that may not always work. For example, I'll just give you a case. It says that the delivery guy was amazingly patient. Okay, so this word amazing is there, but the nearest noun to that word amazing is basically the guy, which is not a meaningful feature, not a relevant feature, right? But the infrequent features are also seen to be comprising of that 10 to 15% of the overall features, so that doesn't create a lot of problem over there, and can be manually, annotated that whether that's a meaningful feature or not. Okay. So that's the algorithm basically. So it's let S be a sequence of sentence, let F be a set of frequent features, and let O be the opinion word associated with these frequent features. And so for each of the sentences in S, if none of the elements of F is in the sentence, means if the feature F is not present in the sentence, but if at least one of the elements of O, means if at least one of the opinions associated with these frequent features is present in the sentence, then the infrequent feature is going to be the nearest noun or noun phrases of the opinion. Okay, so that's how the infrequent feature is mined. Huh? Why do I? So basically, that different manufacturers may have an interest about what the customers are talking about. The customers doesn't have much interest about the infrequent features. But the manufacturers sometimes needs to know that what their customers are mentioning, and why they're mentioning about that. For example, the feature RAM, it's not usually mentioned, but a few number of customer mentions about RAM and share some positive or negative viewpoint about that. Right? So this infrequent feature mining will actually help us to extract that. Yeah, so the buzz of the word is very low. Infrequent means that it's not basically very frequently mentioned in the reviews. Okay, so frequent means it's very frequently mentioned, right? So yes, see that we were using association rules mining, and we said that a noun or a noun combination will be interesting if they satisfy a minimum threshold. Right, so we were deciding upon a threshold that if the support is more than 0.01, then I will consider these features as, that frequent features. Okay, but there will be a lot of features which doesn't satisfy that benchmark, but actually are features. Okay, so. Okay. And so finally we'll come to the summarization part, that what we can do is that we can add up all the positive opinion orientations for a particular feature. We can add all the negative opinion orientation of the features and multiply it by -1 to actually make it positive. And then the positive percentage will be, the positive divided by the positive plus negative, and the negative percentage will be negative divided by positive plus negative. So in that way, it will be, so we will be able to get the percentage of positive opinions associated with the particular features, and the percentage of negative opinions associated with a particular feature. Right? Yeah. So the entire framework, that how it's sound, that the system that was proposed for the feature-based opinion mining looks like this. We have the review database. First, we identify the frequent features using that framework. Okay. So from the frequent features, we mine the opinion words associated with the frequent features, and the opinion orientations associated with each of the opinions. Okay. Now, using the frequent features and the opinion words, we will mine the infrequent features. Okay, and finally we will generate a summary. Okay, so like the way that I just showed you, like this way. So that we were able to mine this, that go to that level where we were actually getting even the body of the phone coming up. So what the people have, means the opinion holders have mentioned about the body of the phone, and like 89% of them has mentioned a positive opinion, had a positive opinion about the body. We even had the price, the performance. Let's see the price, Yeah. Comes in the? Yeah, yeah. Miscellaneous options are basically, there's something that we club them together. Okay, yeah. So we club these features together because the buzzwords weren't enough, for us to show that in the graph. Okay. So that is it. Thank you very much. I will welcome any questions that you have asked. Yeah. Questions? Come again? You're talking about sarcasm again.
Just one input, and I would like to get your inputs as well on that. So if you consider the Amazon reviews, right, and if I want to identify the sarcastic statement in that, so that sarcastic statement will have all the positive words like good, amazing,
Right,
and the
right.
one what you have. But the rating also we generally ask the users to give. Suppose the rating is 1 or so, and they have the positive, so that we consider the sarcastic one in the Amazon reviews and Flipkart.
Yeah, that may be a good indicator as well, that
Yeah.
that someone is talking very good about the phone, but about the product, and giving a very
Low
low
rating.
rating can be
Yeah.
a sarcastic comment.
Sarcastic comment.
Yeah, so if there is kind of disagreement between the rating and the review, then we can say that that's
Okay. Yeah. Thank you.
yeah. Yes.
area specific language would come like English.
There is a problem with that. The reason why we couldn't handle those words is that the part of speech algorithm that we were using is a sequential algorithm, right? So it won't understand that if anything is written in some other thing other than English. Otherwise, means unless we have something like that, means a part of speech algorithm for Hindi or Bengali specific to a regional language. Okay, so because the entire thing actually depends on that one thing, right? And even though that another challenge that you will face is that uh, suppose I'm saying that in Bengali, okay, front camera ta khub bhalo chilo. It's in a Bengali word. Now the front camera is an English word, but the rest of the things are Bengali. So again, the POS speech algorithm will fail over there. Yeah, yeah, yeah. No, the most we have done over here is that we were doing the fuzzy matching for spelling corrections. Okay, but again, so that works for some very particular case. For example, if someone is saying awesome as OSSUM, again that you cannot do anything with that. So yeah, we can. No, we can predefine anything, but for that you need, first of all, you need a lot of data, okay, and you need a lot of resource actually to annotate those things, right?
Yeah.
What is it, LDA?
First a sentiment analysis, then an LDA, apply and rate with a noun filter, almost whatever results you're looking for can be achieved. So I'm just thinking,
No, how is LDA going to help us in that?
LDA will actually group the words based on the frequency of words and based on the n-grams.
Yeah, that is true. You know, what we have seen is that
Again, if you have a noun filter on that, finally you do a rate filter with noun filter.
the reason, you know, that why LDA doesn't work very well is because in one particular review there is mentions of multiple features. So there is not a segregation of one set of reviews where they mentions only about the phone, right? So it groups say that's a number of reviews saying that only phone appears.
Exactly. So LDA does that. The next step you involve rate. You have a word-based or n-gram-based score for each and every word. So you get a score for a certain topic. And you
Right.
rate which topic it is, and you can probably figure out. But also you have a sentiment on that. So I just
Can be tried out, you know. So I'm not sure that whether that will work or not, but definitely worth trying.
Uh, so I really like your talk. Just one thing, you gave example of Flipkart review. So it's I just for information, it's not just the rating of the when it matters the features. It's actually the review based on the way you did positive and negative. When you say camera is 4.1,
So they're
it means
scaling it to 5.
it's based on the positive and negative
Yeah,
reviews.
thanks a lot.
Yeah.
You're from?
Flipkart.
Ah, thanks. See, I was just hoping that I get someone in the audience who is from Flipkart and will correct me on this, you know, because I tried to find a lot of information on that, but we didn't really. Yeah, thanks a lot for the information.
So, WordNet gives you a static rating or like a one sentiment number.
It doesn't
for,
give us a rating at
I mean,
all.
a number for a sentiment for every word.
It doesn't give us that as well.
But it's fixed. Whatever sentiment it gives you for every word is fixed, right?
We don't get sentiment from WordNet.
Like
So WordNet
positive-
is not for sentiment. WordNet is how the words are structured
Right.
in a dictionary. Yeah.
But the structure is static, right? So if good is a positive word, it will always be a positive word, right? But when it comes to opinion, depending upon your feature, the same adjective might be a good thing or a bad thing. Like, for example, long battery life is good, but long charging time is bad. So how can we kind of account for that?
So we actually need to create a dictionary for the domain-specific opinions. Yeah, that is very important, right?
But this is the same domain. It's like in the same domain,
Yeah,
the same
in
word
the
can
same
have
domain
two
that
meanings.
if you feel like, you know, that if you find out, so these are the reviews coming up, these are the opinions coming up. First of all, WordNet doesn't give us an opinion. So we get the opinions from some other dictionaries. Okay, so it's Affine or something, Centisco or some from those things.
Is this process flow a domain-specific process flow for arriving at the sentiments, or
Now, we have basically tried that out for digital cameras, laptop, and phone. So it's working well for all these three things.